Hi guys, this is Ritesh. Today I am going to explain you the concept of minimization of DFA. So, before going to the concept of minimization of DFA, let us see what is equivalence. Now let us take two states P and Q. So, we can say P and Q are equivalent when if P is given input of W, it reaches the final state, and Q, if we give any input, if it reaches final state, then we can say both are equivalent. Or if P doesn't reaches the final state and Q also doesn't reaches the final state, then we can say both are equivalent. Only in the case if both reaches the final state or if both doesn't reaches the final state. It can be any final state, like if we have two final states in the diagram, then it can be okay for equivalence. So by this we can merge two states. If length of W is mod W equal to 0, then both states P and Q are called zero equivalent. If length of W is 1, which means if I see a single symbol and if they are following the property, if the length of W is 1, then we can say it is 1 equivalent. And if the length is 2, then it is 2 equivalent, and so on. If the length of W is n, then it is known as n equivalent. So like this. So now this is finite automata DFA. Now I am going to minimize this finite automata DFA. So actually minimization of finite automata DFA means reducing the states. So now there are 1, 2, 3, 4, 5 states. So I should reduce the states to its minimum level. First we have to check whether first we have to see the starting state and the final state. Now if there is any state like it cannot be reachable, like final state or initial state, let us suppose there is Q5 here, and if it is like this, like any input, if it is like this, then we have to delete this because it cannot be reachable by the final state. So every state must be reachable by the final state or initial state. Let us consider Q0. Q1 is reachable by Q0, Q2 is reachable by Q0, and Q3 is also reachable, and Q4 is also reachable. So this we have to not consider. Now let us draw this state transition table of this diagram. Q1, Q2, Q3 and Q4. Now Q0 is the starting state, so, and Q4 is the final state. Let us mark this as star. Now see this. When Q0 when A is given, going to Q1, and Q0 on B is going to Q2, Q1 on giving B is going to Q3, and Q1 on giving A it is going to Q1, then Q2 on giving A is going to Q1, and Q2 on giving B it is going to Q2, then Q3 on giving A is going to Q1, and Q3 on giving B is going to Q4, Q4 on giving A going to Q1, and Q4 on giving B is going to Q2. So this is the transition table, and wherever Q4 is there, just mark this star. Okay, only 2 Q4s. Okay. Now try to find out the zero equivalence sets. Next, zero equivalent sets. Zero equivalent sets are nothing but, first we have to write, we should be separate the final states and non-final states. So write the non-final states here: q0, q1, q2. So q2 and q3. So these are non-final states, and the final state is q4. Okay. So this is all about the zero equivalent set. Now let us consider one equivalent set. In this, let us consider q0 and q1. Let me mark here q0 and q1. So q0 on giving A, it is going to q1, and q1 on giving A, it is going to q1. q0 on giving B is going to q2, and q1 on B it is going to q3. So in zero equivalence sets, both q2, q1, q2, q3 are in the same state. So now in one equivalence state also, we consider q0 and q1 in the same state. So now let us consider q1 and q2. q1 and q2. Here let me mark this q1 and q2. In q1 on giving A, it is going to q1. q2 on giving A, it is going to q1. So both are in the zero equivalence same state. And q1 on giving B, it is going to q3. q2 on giving B, it is going to q2. So both q2 and q3 are in the same state in the zero equivalence state. So now q2 is also in the same set. Now let us consider q2 and q3. q2 and q3. Let me mark q2 and q3 here. So q2 on giving A going to q1, and q3 on giving A is going to q1. So both are in the same state. And q2 on giving B is going to q2, and q3 on giving B is going to q4. But q4 is in another state. So this will be the, so q3 will be in the another state in first equivalence. So this will be q3 separated from the above, separated from the zero equivalence set, and this will be q4. So now we got three sets, and again now we have to consider two equivalence state. In this we will be considering these again. Let me consider q0 and q1 and q3. Okay, q0 and q1. q0 and q1 on giving A, both are going to q1, and q0 on giving B is going to q2, and q1 on B is going to q3, and q3 is in the another state in the first equivalence. So now these both are not equivalent. So now q0 is another state and q1 will be another state. Now let us check q1 and q2. In this q1 and q2, q1 and q2 on giving A, both are going to q1, and q1 on giving B is going to q3, and q2 on giving B is going to q2. So both are in other different states. So q1, q2, q1 is another state, q3 will be another state, q4 will be another state, q2 will be in this state. Now let us consider q0 and q2. So q0 and q2 on giving A, both are going to q1, and q0 on giving B going to q2, and q2 also on giving B is going to q2. So in second equivalence they both are going to this same state in the first equivalence. So now for the third equivalence, in third equivalence, if I consider q0 and q2 the same input, the A, they will be going to the same state, and B also they will be going to the same state. So we should stop here. And if we go on like n equivalents, you will be getting the same 4 states. Now let us draw the table for these 4 states. Like Q0, Q2 is one transition state, Q1 and Q3 and Q4. Now Q0, Q2. Abra. So now let us see the transition table and draw the transition diagram. On giving for Q0, on giving A input, it is going to Q1. So Q0 on giving A input, it is going to Q1, and Q0 on giving B, it is going to Q2. So on giving B, it is going to the same transition state. Now Q1 on giving A is going to Q1. So it will be Q1, and if we give input B, then it is going to Q3. Next Q2 on giving A, it is going to Q2 on giving A, it is going to Q1, so it will be here only. And Q2 on giving B also goes to Q2, so it is going to here only. Next Q3 on giving A, it is going to Q1. Okay, it's here then. And Q3 on giving B is going to the final state. This is the final state, Q4 on giving B. Next Q4 on giving Q1, on giving A, it is going to Q1, so here it will be A. And if we give B, then it is going to Q2, so here it will go. So this is, now there are 1 2 3 4 states. Previous it was 1 2 3 4 5 states. Now we minimize that to 4 states. This is the minimization of DFA. Thank you.